Welcome to this fourth lecture of Introduction to Logic course. In the previous lecture, we have seen the relationship between the truth values of the statements and the validity of an argument. And in the end, we have defined the notion of validity in this way, that a deductive argument is valid when it is not possible to have all its premises true and conclusion false. And you can think of a variety of options where you decide whether the statement is true, premises are true, or conclusion is true, and then what would be the fate of the argument as a whole. You can also think of different questions on that ground. But suppose I ask you that if all the statements are true in an argument, whether argument is valid or invalid, what would be your answer? You think of your answer. If all the statements in an argument are false, do you think that the argument will be invalid? There is no possibility of having a valid argument with all false statements. So we have explored all these options. You can approach to the discussion in various ways and formulate statements. And normally in examinations, we ask true or false statements. So we take 2 or 3 statements from this section, so you can learn, you can develop your questions and try to answer them. If you find some difficulty or if you have doubt, you can ask your question. Now, we are moving from here to another interesting aspect of the argument. We have seen that the statements or propositions are the basic constituents of argument. And in order to see whether an argument is valid or invalid, we require certain methods, certain principles, certain rules. So in order to arrive at the understanding of the methods and principles to test the validity of an argument, we need to have some basic tools in our hand. And we are going to move to the technique, which is a symbolic technique. In fact, it is called symbolic logic, where we test the validity of an argument by using symbols and seeing the relationship between different symbols. But let me tell you in the beginning that we have started with the understanding of proposition statement. So in this part of deductive logic, we consider proposition or statement as a unit. And then we try to see the relationship between different propositions, different statements. And by seeing the relationship between different propositions, we arrive at certain conclusion. So for that, we symbolize statements. We adopt symbols to represent statements, and we symbolize the whole of argument by using a unique symbol for each statement. And this way, we rewrite the symbolic form of an argument and then apply methods and rules to see whether it is valid or invalid. So To be able to do that, we need to start with something very simple, how statements are symbolized. And you know that all the statements can be divided into two broad categories. Some statements are simple statements, and some statements are compound statement, very complex kind of statements. So we first try to define what is a simple statement. Statement or proposition, as you know, we are taking both the expressions in the same sense. They mean the statement. Proposition is the meaning of the statement, and both are integral, right? Statement and its meaning are not physically two things, right? So we therefore take statement and proposition in the same sense. So all statements taken together are classified into two groups: simple statement and compound statement. So we define simple statement. What is a simple statement? A statement which represents a very simple fact or a state of affairs. Consider, for example, it is raining. It is raining. This is a simple statement. It represents a simple phenomenon, and look into the reality, we see that it is raining. Then this statement, it is raining, becomes true. And if in the reality there is no rain, then this particular statement is false. So we adopt a convenient symbol to represent the whole of statement. Now, normally we follow one very conventional way of choosing a symbol. We adopt the capital letters from A to Z to represent any statement. And usually we go by a particular letter in the statement, in the words of the statement, to choose a convenient symbol. And the purpose of choosing a symbol is to refer to this statement, and we adopt a convenient symbol. We choose a convenient symbol so that we don't forget that this particular symbol was taken for this statement. So in this case, we have adopted R, capital R, to represent the whole statement. It is raining. R we have taken from the first letter of raining. So whenever it occurs, we will know that R stands for it is raining. Suppose you have a statement where there are several simple statements, and there you find that a symbol may be confusing, and we may forget that the symbol was adopted for this statement, because the words occurring in the statements have the similarity of beginning with same letter. So we can arbitrarily take a particular symbol, but only precaution which is required is that whenever we choose a symbol for that particular statement, that symbol is reserved for all the occurrences of that statement. We do not adopt a different symbol for a different occurrence of the same statement. And we can arbitrarily choose any symbol. The only concern is that wherever that statement occurs, we need to put that chosen symbol. So this way we start symbolizing our argument by choosing unique symbol for our statements in the argument. So it is raining. For that, we have adopted R symbol. Similarly, Mohan is a boy, Kavita is a student, or Jammu is a city. You can just consider any simple statement and you choose a convenient symbol to represent that statement. So this is the way we represent a simple statement in symbolic form. Now, depending on the definition of a simple statement, we define compound statement. Its definition is something like this: a statement in which at least one simple statement occurs as its constituent part. What it means is that in a compound statement, there is at least one simple statement. There may be many simple statements, and therefore the complexity of statement, compound statement, will increase. That is fine. But the minimum condition for any statement to be called compound statement is that a simple statement occurs as a part of the whole compound statement. That is the logical definition we adopt for compound statement. Now consider, we have taken this example, it is raining for an instance of simple statement, and we have chosen R symbol. Suppose we take the negative counterpart of the same statement, that is, it is not raining. Now, it is not raining is a compound statement. It is not a simple statement. Why it is a compound statement? You can see the rephrasing of this statement in the form given below. It is not the case that it is raining. So now you see this simple statement is exactly occurring here. And the rephrasal of this compound statement in this form explicitly shows it, right? And it is not the case is the negation of this simple statement. So it is not raining means the same thing in this statement, that it is not the case that it is raining. Now you have seen that we have adopted R symbol for this simple statement. So we are keeping this symbol here also. Now consider, it is not the case. This is the negation of this simple statement, right? So in logic, we adopt this particular symbol on your computer keyboard called tilde or tilde. This is the negation of the simple statement R. So when we are to symbolize that it is not raining, what we are going to write? We will write negation of R. So we will put tilde before R. And that is the symbolic representation of a negative statement. And since there is something in addition to what is just simple statement, and therefore it is not a simple statement, it is called compound statement. And we will learn further that there are different forms of compound statement. This is the simplest form of a compound statement. When we have the denial of a simple statement, that is the simplest form of a compound statement. We need to simply put a negation before the symbol representing a simple statement. And to represent the truth value of any statement, we make a table. This is called truth table because it represents the possibilities of truth value associated with any statement. So suppose P is a simple statement and negation P is the denial of the simple statement. A simple statement is true, therefore its denial is false. So in this case, when it is raining is the positive statement, simple statement, and the state of affair or the fact in the reality tells that there is a rain, so it is raining is true, and therefore it is not raining becomes false. And suppose it is not raining actually, and when we say it is raining, so it is raining becomes false, and it is not raining becomes true. So considering the possibility of truth value with reference to a simple statement, we have learned that a statement is either true or false. That applies to simple as well as compound statement. So a simple statement is true, and then its negation becomes false. And if a simple statement is false, then its negation becomes true. So this is the truth table to represent the truth value of any statement. And these things will become clearer when we proceed further. So consider another form of compound statement. We have seen earlier the negation of a simple statement, and that we have taken as a compound statement. That was the simplest form of a compound statement. Now we are moving to a little complex form of a compound statement. So the first complex form which we discuss in our logic is conjunctive compound statement. And in short, it is called conjunction. Conjunction is the short form which we adopt for conjunctive compound statement. And which kind of statements are conjunctive statements or conjunctions? We find certain indicators. The way we have discussed certain indicators with respect to the identification of conclusion and premise in an argument, we are following the same pattern. So there are certain indicators where when simple statements are combined with these indicators, then we call them conjunction. So I have taken some example, and because, since, moreover, etc. So when two simple statements are connected or combined with these expressions, we call that statement a conjunction, compound statement. Consider, for example, Narendra Modi is the Prime Minister of India and Mehbooba Mufti is the Chief Minister of Jammu and Kashmir. So consider these two simple statements. Narendra Modi is the Prime Minister of India and Mehbooba Mufti is the Chief Minister of Jammu and Kashmir. We adopt a symbol for representing a simple statement. So Narendra Modi is the PM of India is one simple statement, and the other simple statement is this. So we choose one symbol for this simple statement and another symbol for this different simple statement. So for the sake of convenience, and it is, as I said, arbitrary, you can choose any symbol, but remember always that you use that symbol to represent that particular statement for which it is chosen. So for the sake of convenience, I have taken first letter of Narendra Modi word, so N, and then Mehbooba Mufti, so M word, letter for representing the whole simple statement. And this connective, the conjunction, is represented with the help of dot. That is the logical notation. There are other methods also. For example, somewhere you may find inverse V. In some books you will find inverse V adopted for representing the conjunction. But here in our course, we follow this dot. So to symbolize this whole compound statement, we write N dot M. N dot M. That becomes the conjunctive statement. N dot M becomes the symbolization of this whole conjunctive compound. So taking terminology from the conjunctive compound statement, N is one conjunct, M is another conjunct. So there are two conjuncts in this particular conjunction, and this is the relationship between them, that is called conjunction. Relationship is also called conjunction, and these are conjuncts. So N dot M. But when we formulate, when we write a formula, so formula is always written with the help of small letters PQRS. And in this introductory course, we can manage propositional logic with only 4 symbols, PQRS. So all formulas are written by choosing PQRS in small letters. So consider if P is one simple statement, Q is another simple statement, how many possibilities of their conjunction exist? P, Q in conjunctive form written as P dot Q. Now we have seen that a simple statement is either true or false, and the simplest form of compound statement is dependent on the truth value of the simplest form of a compound statement is dependent on the truth value of the simple statement. The truth value of the simplest form of the compound statement is dependent on the truth value of the simple statement. And then the negation inverses the truth value, right? So it is rather easy to decide when there is just one simple statement becoming part of a compound statement. But when there are two statements, they have got different value, right? One statement is either true or false. The other statement is also either true or false. So there are two statements. So how many possibilities are there when they come together? And remember, howsoever compound statement a statement is, the whole value of the statement will be just one. Since it is one statement, howsoever complex it is, the whole truth value will be one. So we adopt a mechanism to calculate the truth value of a compound statement, and we design truth table to calculate the values, the possibilities of the values of a conjunctive statement. Same thing we will do in other compound statements. So this is the simple formula. N is actually the number of simple statements participating in a compound statement. So this formula is adopted to make truth table and also to see how many possibilities regarding the truth value of a compound statement could be, right? So 2 to power n, n is the number of simple statements. So in this case, we have two statements. So how many possibilities could be there with respect to the total value of a compound statement, considering two statements as the participant in that compound statement? So we can think of both these statements being true. We can think of P being true but Q being false. Also, we can think of P being false or Q being true. And we can think of P and Q both being false. So these are only 4 possibilities with respect to their combination of values, right? So consider these 4 possibilities, how these 4 possibilities are calculated. So we can just put 2, n is number of statements, so 2 to the power of 2, so 2 to the 4. So there are 4 possibilities with respect to the truth value of their conjunction. They can conjoin, they can combine in these 4 possible ways, and we can calculate their truth value in this way. So how to construct a truth table? When we see that there are 2 simple statements combining to form a conjunctive statement, so we arrive at this decision that 2 to power 2 equals to 4. So there will be altogether 4 rows, 1 row, 2 row, 3, 4. So how do we construct a truth table to calculate their value of conjunction? So we got this information from this formula that there will be 4 rows. So we divide this 4 by 2. So below P, first we write 2 T's and then 2 F's. And then half of it, we have got 4 by 2 equal to 2. So we have written 2T and then 2F. And this 2 is further divided by 2. So we have got 1. So below Q, we are going to write 1T, 1F, 1T, 1F. Suppose there were 3 statements in this conjunction. So what would be the total number of possibilities with regard to their truth value? It would be 2 to power 3, and that will become 8. So suppose these 3 statements were P, Q, R. So 8 by 2, we got 4. So below P, we will write first 4T and then 4F. Then below Q, we will write 4 divided by 2, so 2. So below Q, we will write TT, FF, TT, FF this way. And then below R, we will write TF, TF, TF. So that's the way we calculate the possibilities of truth value. Now, there is a rule with regard to the calculation of the truth value of a conjunction. The rule is this: a conjunction is true only when all the conjuncts are true. This is the rule regarding the calculation of the truth value of a conjunction. So a conjunction is true only in one condition, where all the conjuncts participating in that are true. So look at this. P is true here, Q is true here. So this line P dot Q has got aggregate truth value true. In all other cases, whether Q is false or P is false or both are false, in all other cases, P dot Q becomes false. So P dot Q is true only in one condition where P and Q both are true. That is the rule to calculate the truth value of a conjunction. And these values are the calculated values depending on the values of P and Q. So if you want to call it in logical terms, so the this expression P dot Q is a compound a truth function. What it means, the value of P dot Q is dependent on the truth function, the value of P and Q. So the value of the P dot Q is the function of the value of P and Q. And that is why it is called truth functional statement. Its truth value is dependent on the values of its participant. So this way we calculate the value of a conjunction. Now move on to another kind of statement, compound statement, called disjunctive compound statement, or in short, disjunction. So how do you identify that this particular statement is a disjunctive compound statement? These are the markers. When two statements are connected with either or two statements are connected with unless, then we say that this is a disjunctive compound statement. Consider, for example, either Narendra Modi is the Prime Minister of India or Barack Obama is the President of USA. To represent, we follow the same pattern of representing simple statement. We have adopted a symbol N for representing this simple statement. We have adopted B symbol to represent this simple statement. And this disjunction, either or, is represented with the help of small v. We call it wedge. So when we are to symbolize this statement, we will write N wedge B. I have put this square bracket just to identify, otherwise we simply write like this, N wedge B. Now, N has got a value, B has got another value. So what would be the aggregate value of the whole disjunctive statement? So for this, we have another formula. Up to here, if you look at the table, it is similar to what we have seen in the case of conjunctive statement. P, Q, table we have designed in the same way, 2 to power 2. So 2T, 2F, TF, TF, and then P wedge Q. So focus up to here. This, the value of P wedge Q is calculated on the basis of the values of P and Q. And P wedge Q is false only in one condition, when P and Q both are false. In all other situations, P, Q being true, so P wedge Q will be true. P being true, Q being false, so P wedge Q will be true. P being false, Q being true, so P wedge Q will be true. So P wedge Q will become false only when all the disjuncts P and Q both are false. In other cases, it is true. Now, here there is a question that in ordinary language, we use this either or expression in two situations. Now, what is that situation? Suppose you go to any mall and there you find an offer suggesting that either 3 shirts or 4 plates, either 3 shirts or 4 plates are for 100 rupees. Suppose this is the offer. Either you buy 3 shirts or you buy 4 plates, you will pay 100 rupees. Now, can you buy 3 shirts and also 4 plates and pay just 100 rupees? Would that be possible? Here, if you choose 3 shirts, you have to give up 4 plates. You cannot take both for 100 rupees. Or if you are going to take both, then you have to pay 200, right? So when it is said that either 3 shirts or 4 plates are for 100 rupee, here you cannot consider that you can take shirts and plates both as 100 rupee. But look at the situation here, either P or Q. When P and Q both are true, that means if you are taking 3 shirts as well as 4 plates, can you pay just 100 rupee? That is not possible, right? But suppose we find a scholarship which is meant for you. Suppose the condition for a scholarship is that it is given to either a poor student or the student who gets top grade. A scholarship is given to that student who is either poor or gets top grade. So how do you write this disjunction? Either a student is poor or the student gets top grade, he will be given scholarship, or the scholarship is meant for either poor student or the topper. Now suppose a poor student tops also. A poor student gets top grade also. So can we deny the scholarship to that student? That would be a very crude form of injustice, right? So consider either 3 shirts or 4 plates, one situation. Second situation, either poor or good grade or top grade. We are using either or expression in both these situations, but our treatment with respect to these two statements is different, right? So how to differentiate? In logic, we adopt two notations to represent these two kinds of statements. One is called inclusive sense of disjunction. Both are disjunctive statements. One is called inclusive sense of disjunction. That means when a student is poor and also gets a good grade, the student will be given scholarship. The student cannot be denied scholarship. That means if P and Q both are true, even then P weighs Q is true. But in the case of t-shirt and plates, or shirts and plate, if you take both, you cannot just go away by paying 100 rupees, right? So to clarify that kind of disjunction further, what we say that kind of just disjunction as exclusive sense of disjunction. And we add that either you purchase 3 shirts or you purchase 4 plates, you will have to pay 100 rupees. But you cannot buy both for 100 rupees. So either this or that, but not both. So this way we clarify our intention, right? So inclusive sense of disjunction suggests that even if both the disjuncts are true, the disjunction will be true. But in the case of exclusive sense of disjunction, if both the disjuncts are true, then the total value of the disjunction will be false. And to demonstrate that, we have conjunction with P weighs Q, and what we conjoin here, we conjoin not both, negation P and Q. That means either you take P or Q, but is also a marker for conjunction, but not both. You cannot take P and Q both. Now, if you calculate the value by writing the truth table, you will easily see that P weighs Q is true here, and P dot Q will be true because this is true and this is true. Refer to the previous table, conjunction. If P and Q both are true, then P dot Q will be true. But then you put negation. So the total value of P dot Q will become opposite, right? So P dot Q is true. Therefore, negation of P dot Q becomes false. So if this part is false and this part is true, so you know true conjunction false becomes false. This way, you clarify the difference between inclusive sense of disjunction and exclusive sense of disjunction. So you look at here, you see that total value of the exclusive sense of disjunction is false when both the disjuncts are true here. So if P is true, Q is true, then P weighs Q, conjunction, negation of P dot Q becomes false. Similarly, you can calculate all these values. So this way you need to construct truth table and calculate the value of disjunctive statements. There are examples given in your book, textbook. So you try to symbolize them, find out their truth value, and we will see if you face any difficulty in calculating the values. So that will be the task for your next class, right?